Good morning everyone, my name is Danilo Giordano and this video is for the PhD Prize Award 2017. First of all, let me briefly introduce myself. I started my PhD in 2014 under the supervision of Professor Marco Mellia. During this year, I had the opportunity to cooperate either with industrial partners such as Nervous, a company with headquarters in California that I visited for a period of 2 months. This cooperation allowed me to publish 2 papers. One of them also became a patent and won the best paper, but I also cooperated with research center, in particular CADA, a research center located in the UC San Diego University, where I spent 6 months during my last year. This cooperation allowed me to publish 1 paper that won the prestigious Applied Networking Prize given by ITF. At the end of my PhD, in order to continue my research career, I submitted a project related to future evolution of car sharing system to the Civil Energy Institute project. At the end won the grant. However, most of my PhD was focused on monitoring the internet network. To do so, I divided this huge problem in 3 parts. The first part is monitoring the clients. The clients are all of us accessing the internet, asking for content such as video or news, or asking for services such as search engineering. All our requests then goes to the second part that I want to monitor, which is the internet infrastructure itself, which is composed by several hundred thousand of nodes and in charge to bring our traffic from us to the server side, which is the end of the road, and which is composed by those computers that are in charge of serve us the content we were looking for or give us the service. To perform all these monitoring experiments, there are 2 main steps that needs to be done. First, the data acquisition phase of each step of each monitoring problem, and secondly, understand which methodology works best to analyze the acquired data. As for the first step, I used dataset already available, so my contribution is on the second part. For the methodology, I use methodology coming from mathematical and statistical world. In particular, I use mathematical solution to characterize some dataset and statistical tools in order to try to find correlation in the characterized data. In particular, for the client monitoring problem, I use mathematical tool to create a client's fingerprint based on which website the client visited, and then I use statistical tool to try to re-identify this client among many other clients over time. Then I use also machine learning solution in order to create a model of the data. For instance, as I will show you briefly later, I use this machine learning solution on the server study to simplify the dataset I had available. Finally, I also use some big data frameworks in order to analyze huge amount of data when a single computer was not enough, and so I needed a cluster of computers. I used big data framework when I had to deal with the internet infrastructure, as I had terabytes of data to study the internet infrastructure growth, looking also for malicious activities. As for the server study, I decided to study the YouTube infrastructure, as it has a very massive infrastructure composed by several thousand of servers which are worldwide located and which manage about 20% of worldwide traffic. Unfortunately, sometimes these servers have anomalies as they do not work very well. These kind of anomalies sometimes have impact on the clients, which are not able anymore to watch YouTube videos or watch YouTube videos very badly. Due to this kind of problem, the clients often go to complain to their ISP that wish to have a tool able to identify this anomaly in time and possibly suggest how to react to this anomaly. For this reason, I created this methodology that started from a dataset available at Polito, dataset that for a group of clients gives me the information about which video they viewed, how long time they took to download its video, and many more information. Does the following. First, group the YouTube server in few groups each time. To do so, it used the unsupervised clustering technique called dbScan. Then, by analyzing these groups over time, try to identify changes over time, possibly anomalies. In particular, one of the anomalies highlighted is this one in March 2014, where a group of servers called Break Frankfurt had a throughput lower than 500 kilobit per second 70% of the time, while the cache in the server behaving well cold Milan and good Frankfurt had a throughput greater than 1000 kilobits per second most of the time. To conclude, I would like just to say that monitoring is a fundamental task nowadays to understand our network and keep this knowledge updated. Unfortunately, each monitoring problem asks for specific methodologies such as the big data frameworks that are fundamental frameworks to cope with the growth of volume of data. Thanks for your attention.